Hi, I welcome you back to another tutorial. My name is Protocol. In this tutorial, we shall discuss De Morgan's laws of sets. De Morgan's laws of sets. There are two De Morgan's laws in sets. The first one is De Morgan's law of union. What does this law state? This law says that if you have a universal set U and you have another set, let's say set A and B, and set A and B are subsets of the universal set, then this law says that if you find A union B all prime, the answer you are going to get will be the same as A prime intersection B prime. And this law is called the De Morgan's law of union. Let's look at the second law. It says that if you find A intersection B all prime, it will be the same as A prime union B prime. And this law is what is called De Morgan's law of intersection. Let's take an example to see how these laws work. So, given that the universal set, that is U, is equal to the first 5 counting numbers. So we have 1, 2, 3, 4, and 5. And given set A, which is a subset of U as prime numbers. So we have 2, 3, and 5. And give you another set, let's say set B, which is also a subset of U as even numbers. So we have 2 and 4. Okay. Now, show that 1, A union B all prime is equal to A prime intersection B prime. 2, show that A intersection B all prime is equal to A prime union B prime. Okay, so let's use this example to show that 1, A union B all prime is equal to A prime intersection B prime, and also A intersection B all prime is equal to A prime union B prime. Okay, let's take the first one. So we have to show that A union B of prime is equal to A prime intersection B prime. Okay, so let's find A union B of prime first. In order to do that, we have to find A union B first. So we have A union B to be equal to, so we have set A here, and we also have set B here. Therefore, A union B, we are going to combine all the elements in set A and all the elements in set B in a single set. So as you can see, we have 2 in both sets, we have 3 in set A, we have 4 in set B, and we also have 5 in set A. Therefore, A union B will be equal to 2, 3, 4, and 5. Good. Hence, A union B of prime will be equal to, now, A union B of prime will be equal to all the elements that can be found in the universal set but cannot be found in A union B. So let's check the universal set. 2 can be found in A union B. 3 can also be found in A union B. 4 and 5 can also be found in A union B. Therefore, the only element that is in the universal set that cannot be found in A union B is 1. Hence, A union B of prime is equal to 1. Let's find A prime intersection B prime. So we have A prime intersection B prime. What does it mean? Let's find the A prime first. A prime means that all the elements that can be found in the universal set but cannot be found in set A, those elements are the A prime. So clearly, 1 and 4 are the only elements that can be found in the universal set but cannot be found in set A. Hence, A prime will be equal to A prime will be equal to 1 and 4. Good. Let's now find B prime. B prime also means that all the elements that can be found in the universal set but cannot be found in set B, those elements are what we are referring to as B prime. So clearly, the elements are 1, 3, and 5. These elements are the elements that can be found in the universal set but cannot be found in set B. Therefore, my B prime will be equal to 1, 3, and 5. Hence, A prime intersection B prime will be equal to A prime intersection B prime. Means that all the elements that can be found in A prime and also found in B prime. So let's check and see the element that we can see in A prime, and same element can be seen in B prime. Obviously, one can be found in A prime, and also one can also be found in B prime. And one is the only element that can be found in A prime and B prime. Hence, A prime intersection B prime is equal to 1. As you can see, A union B all prime is equal to 1. And also, A prime intersection B prime is also equal to what? 1. Hence, the first law, that is the De Morgan's law of union, which is A union B all prime is equal to A prime intersection B prime whole, which is equal to 1. So we are able to show that law. Let's go to the second one. We have to show that A intersection B all prime is equal to A prime union B prime. So in order to do that, we have to find A intersection B all prime first. Let's do that and see. In order to do that, we have to find A intersection B first. So we have A intersection B to be equal to, so let's go and look at set A and set B. Let's look at set A and set B. So we have set A and set B. It means that all the elements that can be found in set A and can also be found in set B are the elements that we are going to write in A intersection B. So which elements are found in A and also found in set B? Clearly, 2 is the only element that can be found in both sets. Therefore, A intersection B is equal to 2. Hence, A intersection B all prime will be equal to, so it means that all the elements that can be found in the universal set but cannot be found in A intersection B. So 2 can be found in the universal set and can also be found in A intersection B. Therefore, 1, 3, 4, and 5 are the elements that can be found in the universal set but cannot be found in A intersection B. Therefore, A intersection B all prime will be equal to 1, 3, 4, and 5. Let's now find A prime union B prime. So we have A prime in your B prime. So it means that we are combining the elements in A prime and also the elements in B prime in a single set. So let's check the elements in A prime. So A prime, we have 1 and 4. And B prime, we have 1, 3, and what? 5. So combining these elements in a single set, we shall be having, so let's check. We shall be having 1, 3, 4, and 5. So A prime union B prime will be 1, 3, 4, and 5. As you can see, A intersection B all prime is equal to 1, 3, 4, and 5. And also A prime union B prime is also equal to 1, 3, 4, and 5. Hence, A intersection B all prime is equal to A prime union B prime, which is equal to 1, 3, 4, and 5. Hence, the second law also holds. That is the De Morgan's law of intersection. So as you can see, we are able to show that 1, A union B all prime is equal to A prime intersection B prime. That is the De Morgan's law of union. And we are also able to show that A intersection B all prime is equal to A prime union B prime. And that's the De Morgan's law of intersection. Now, before we go, I would like to give you some examples to try on your own. So given that U, which is the universal set, is equal to S, is such that S is greater or equal to 1, less or equal to 10, where X is an integer. And set P, which is a subset of the universal set, is multiples of 2. Also, set Q, which is also a subset of the universal set U, is factors of 8. Now, if P and Q, as we said, are subsets of U, show that 1, P union Q all prime is equal to P prime intersection Q prime. And 2, show that P intersection Q all prime is equal to P prime union Q prime. And in each of the cases, state the law that is being used. Thank you so much for watching another tutorial. Don't forget to subscribe to my YouTube channel, watch the videos, and share them as well. Thank you so much.